Hello all, let's start section 5.3. 5.3 is binomial probability distribution. First of all, let's understand what is a binomial probability distribution. I'll put the definition here for you. A probability distribution, that has only two outcomes. What are these outcomes? Success or I can say let's say and failure. We call these types of probabilities binomial probability. How? For example, when you are flipping a coin has two sides, correct? Heads or tail. Head or tail, correct? If your goal is, for example, you are flipping this coin like 10 times, and your goal is to get 5 heads, correct, or 5 head, head will become your success. Tail will be your failure. Looking to these examples or looking to the definition of binomial probabilities, we can call on any probability. Actually, we can change most of the probabilities that we learn up to now and call them as a binomial probability. Even you see, if I do the example of dice, correct? A dice has 6 sides, but for example, I'm rolling a dice 6 times and my goal is to get 2 5s, correct? 5 rolling a 5 is success because that's my goal. What is the failure here? Your failure will be the rest, which is 1, 2, 3, 4, and 6. If you roll these, they are the failure, right? You can see, you can change any probability and you can see it as a binomial probability. Before I give you a formula, I'll give you some rules for binomial probability distribution. After that, of course, some notations, and then we jump to formula. Let's start first with rules. There are 4 important rules in binomial probability distribution. I will use red color. Please remember these 4 rules, correct? Rule number 1. Must be a fixed number of trials. Must be a fixed number of trials. How? For example, in the example of dice, I told you that you are rolling a dice 6 times. This is a fixed number of trials, correct? You're rolling 6 times. Or in the example of coin, I told you that you flip a coin 10 times. It's a fixed number of trials. This is what rule number 1 says. Rule number 2. Trials must be independent. The first one, fixed, is important that you have to memorize. Trials must be independent. What is the meaning of independent? It means the outcome, if you remember from chapter 3, the outcome, let's put here also the all of this inside the parentheses, that's the meaning of independent. The outcome of one trial does not affect the others. That's the meaning of independent. For example, when you flip a coin and you get ahead in the first time or first trial, correct? When you do second time, when you flip second time, the outcome of the first one doesn't change the outcome of the second one. Or when you are rolling a dice and you get a 3, when you roll for the second time, that 3 is not going away. Still that 3 is in the dice, right? The outcome doesn't affect the others. The first outcome doesn't affect the others. Or, for example, if you draw a card from a deck of cards with replacement, remember this? With replacement? We talked about this before. With replacement, it means when you draw a card from a deck of cards, after you see the probability, you put back the card in the deck. It doesn't change the probability of the others, correct? The word with replacement means put it back, correct? Replace it back. These types, rule number 2 is talking about independent, and that's the meaning of independent. The outcome of one trial does not affect the others. Rule number 3, each trial has only 2 outcomes. Has only 2 outcomes. What are the outcomes? We just start with this because it's binomial, success and failure. Each trial has only 2 outcomes, success or failure. Flip a coin, your goal is to get ahead. If you get ahead, it's your success. The failure is getting a tail. Correct? Number 4, rule number 4. The probability of success of success, I missed an E here, success, remains the same at all time. Or in all trials. You can say different ways. You cannot change the probability of success. Soon I will do an example and you see we are not changing through the procedure the probability of success. For example, when you flip a coin, the probability of success is 50%. The probability of failure is 50% because you have only two sides. You get a head or you get a tail. It's 50-50. If you roll or if you flip that coins like 10 times, you cannot say, oh, I'm changing the probability of success from 0.5 to 0.7. You cannot change it. It always remains the same. Correct? These are the 4 important rules of binomial probabilities. Now, we learned the rules. It's time to learn some notations that we use in our formula. The first notation is lowercase n. Lowercase n here means number of trials. Correct? For example, in the example of coin, my n was equal 10. I'm flipping a coin 10 times. Correct? N shows the number of tries. Lowercase p, not uppercase, lowercase p. The probability of a successful outcome in a single try. This part is really important, in a single try. Lowercase p shows the probability of success. It represents the probability of success, but in a single try. How? When you flip a coin and your success is, for example, head, what is the probability of getting head? Your lowercase p is 0.5, right? 50%. In one try, in a single try, not through the procedure. Correct? Because students are usually getting confused between lowercase p and uppercase p, which soon I'll put that notation also for you. Correct? Q. Of course, if P represents the probability of successful outcome, Q represents the probability of failing outcome in a single try. Again, it's important. It shows in a single what? Try. See, if I want to explain here for you, for example, when you flip a coin, two outcomes, head or tail. For example, I'm looking for head. This is my success. Head will be my success, and my failure will be getting a tail. What is the probability of having a head when you flip once a coin? Correct? Your probability, lowercase p, is, I told you, 0.5 or 50%. What is the probability of failure? The probability of failure is, of course, also 0.5. Then, from here, I can say something for you. Whenever you add lowercase p with q, it should always gives you 1. And we know that 1 for us here means 100%. 50% plus 50% gives you 100%. Okay, now if I can write this relation, then from here I can solve this equation for p. And I can say p equals 1 minus q. If q is given to you, you can easily find p. Or if p is given to you, you can easily find q. Usually in the problems, the probabilities, because they are fixed, like 30%, 50%, 80%, 70%, even you don't need these. You can think, okay, if the probability of success is 70%, the failure will be 30%. But if it's something like decimal that you cannot kind of think about, use one of these and easily you can find the other. Correct? The next notation is x. X is the number of successes that occur in the n trials. Correct? The number of successes. How to explain this? For example, you flip a coin 10 times and your goal is to get 6 hits. This 6 is actually your x. It's the number. Remember, it's the number. It's not the probability. It's the number of success, not the probability of successes. Last one that I put this notation for you, uppercase P, P of x. This one is probability of getting x. Usually students are confused between x, p of x, and lowercase p. I explained it here to you to do not be confused. Now, in this example, for example, if I'm looking to find what is the probability of success, I will look for the p of 6. Right? Because my success is getting 6 hits. Then you look for the probability of 6. Correct? Let's do an example. In this example, I'll use weighted dice. Correct? I will write the example for you. The probability of rolling a 4 is 30%. The die is rolled 10 times. The die or dice rolled 10 times. Find the probability of rolling exactly 8 fours. Correct? What is important for you in this problem to first find out what is given to you, make a list, and what you are looking after. Let's start this way. If I ask you here, what is your success, even before identifying the numbers? What is your success? Your answer should be rolling a 4, singular form. Rolling a 4 is your success, not rolling 8 fours. Rolling, for example, it's a game. Correct? Rolling a 4 is your success. What is failure? The failure is the other sides, which is 1, 2, 3, 5, and 6. Correct? Or rolling 1, even you can put the word rolling here. Rolling 1, 2, 3, 5, or 6, that's the failure. Now, if I ask you in this example, how much is n? Which number is n? The probability of rolling a 4 is 30%. The die rolled how many times? 10 times. That 10 is your n. How many times you're repeating the procedure or your trial, that's n. Correct? Lowercase p, probability of success. It's given in the problem, even in the first line. The probability of rolling a 4. 4 is your success, right? Is what? 30%. It means your p is 0.3. 30%. If p is 0.3, I can ask you how much is q. Your q will be 0.7. Those of you that you don't know how we got 0.7, we know that q equals 1 minus p. It means q equals 1 minus 0.3, which gives you what? 0.7, 70%. If 30% is the success, 70% will be the failure, correct? X, how much is my x? What is the number of success that you are looking after? 8. Find the probability of rolling exactly 8 fours. X is 8. Correct? Now here you need a formula. You are looking now for the P of 8 or P of X, which is here P of 8. Correct? You need a formula to can solve this problem. The formula for binomial probabilities is P of X equals n factorial over n minus x factorial times x factorial times p to the power of x times q to the power of n minus x. Looks really a long formula. If you want to use it, you can use it, but look here. This part should be very familiar to you because we had similar to this formula, we used it before. Instead of x, we had r, lowercase r there. n factorial over n minus r factorial times r factorials. That was your combination, NCR. But here I'll name it NCX. I want to make this formula a little bit easy for you to can use your calculator. Then I can write P of x equals NCX times P to the power of x times Q to the power of n minus x. Correct? That will be your formula to find a binomial probability. Now, in our problem, P of 8 equals n. N was 10. C, x was 8 times, you can use parentheses, the probability of success was 3%, 30%. It means 0.3 to the power of x, which your x is 8, times the probability of failure, which is 0.7, to the power of n minus x. Your n was 10 minus x, 8. It means to the power of 2, right? Let me erase this and instead put 2 to save some space. Because n is 10, x is 8, 10 minus 8 gives you 2. Now, this part, TC8, or how to find this, I'll bring up my calculator here. I'm lucky now that I got this calculator. I'll show you in this calculator how you can use your NCX. Most of you have TI-84 plus. It's the same. If you only have a scientific calculator, you have a button P or B. I'll show you what is P or B here. If you are using a TI-84, put this number, punch this number first. Punch your n first. My n is 10. After I punch 10, I'll go to Math, click on Math. Now move to the last with your arrow keys, using your arrow keys. Move to the P or B. Those of you that you are using scientific calculator, you have the P or B button somewhere here in the function buttons. But those of you that you are using TI-84, go to P or B. Now scroll down with your arrow keys. Find NCR, which is here, right? Number 3 is NCR. Enter. Now put your x. How much is your x? My x is 8. And again, enter. It gives you the answer. Instead of using this n factorial over n minus x factorial, easily you can use your calculator, which gives you what? 45. Correct? Then I can say P of 8 equals 45 times 0.3 to the power of 8. Again, we need our calculator. 0.3 and TI-84 raising to a power is this button, the arrow, to the power of how much? 8. Click on 8 and enter. It gives you 6 point. Oh, how much was that? Before going down. It was 6.56 times 10 to the power of negative 5. 6.561. 6.561 times 10 to the power of negative 5. times 10 to the power of negative 5 means move your decimal 5 decimal place to the left. Correct? Times 7 square, you can use the calculator, is the same. 7 square gives you 0.49. It means if I simplify this, P of 8 equals 45 times this number becomes 0.0000, 4 zeros, correct? Then 1, it was 6 or 1? 6. 656 or 651. 00661 6561, correct? Times 0.49. Using your calculator, multiply these three numbers. P of 8 equals 0.0014467. That will be your answer for this problem. Correct? This is the probability of getting 8 4s in 10 tries, 10 independent tries. This is the probability of getting 8 4s. Correct? I will stop the first part of the lecture here, because in the second part of the lecture I will cover more for you. I will cover how to use your book, the table that you have in your book, binomial, and also even not using this formula, instead of this formula, how to use your TI-84. Correct? Using TI-84 is easy. Maybe before the book, I'll show you how to use your TI-84 even not using this formula. On the test day, there will be a problem that I will ask you to use the formula. But there are problems that easily I will let you to use your calculator. Okay, now, if you want to solve this formula, this problem without using formula, I'll bring up the TI-84 and I'll show you the process how you can use your TI-84 without using the formula. Correct? What you do, write some notes, click on second, then variance. You see at the top of variance, you have distribution in blue color. When you push second, it means you are going to distribution. Now, go down, find binomial PDF. You see, you have binomial PDF, you have binomial CDF. You are using binomial PDF if you see the word exactly in your problem. P means point, exactly 1 point. You are using binomial CDF if you are using a range of numbers. That it will be my next example. But for time being, just learn how to use binomial PDF for this problem. Correct? Let me go to binomial PDF. Enter. In some calculators, older version, a parenthesis will be open for you. You have to put 3 values using comma. But in the newer versions, this version, or even the color versions, which is the latest version, They are asking for exact values. You see, they are asking you how much is your x value. Our x value is 8. Correct? We have to punch 8. Oh, I'm in normal distribution. Oh, binomial. Sorry, let me go out from here. I come to the normal distribution, binomial. We have to go to binomial, not normal. Here, binomial PDF. Maybe my cursor moved. Again, normal, it doesn't give me, I think my calculator is not clear. Why I cannot clear? Somehow the system is not working because it's online. Binomial PDF. How I can turn it off? I think this way. Yes, let me turn it on again. Now, let me see if we have it in math. No. Second, variance, and you go to binomial PDF. Here, binomial PDF. Enter. Here now. I think before I punched the wrong button in the calculator. Second, variance, then you go to binomial PDF. How many trials? Your calculator is asking you how many trials. We have 10 trials, right? Punch 10. Move down. Your calculator is asking for probability of success. Your probability of success was 0.3, right? 0.3. Down, asking for x. How much was x? The number of successes, 8. Correct? Punch 8. Now, paste, enter. You see, in the older version, this thing will be open immediately for you. If you have those kind of calculators, you put first your n, then lowercase p, then x, correct? And again, enter. You see your answer in the screen of your calculator, and the answer that we just used the formula, they are the same. Even calculator gives you more decimal places. You can use calculator in the next example, but at least I told you there will be one problem in your test that I will ask you to use this formula. Correct? What was the process for TI-84? First, second, then variance, then you go to binomial PDF, parentheses and older versions will be open for you. First, you punch your N, then use comma, then lowercase p, then comma, then X. Enter, and again enter, it gives you the number. Correct? That was how to use TI-84. I'll stop the lecture. I'll do a part 2 of this lecture for you, and I'll do more examples, and I'll show you how to use your calculator. And also in part 2 of the lecture, I'll use the table for you from your book. If you don't have a TI-84, how to use the table at the back of your book. See you all in part 2 of this lecture.